Methylation tetrahydrofolate reductase, or MTHFR, is a gene that encodes an enzyme crucial for processing folate and homocysteine in the body. The MTHFR C677T mutation refers to a single letter change in the DNA at position 677 of the MTHFR gene, where a cytosine C is replaced by a thymine T. This small change causes an amino acid substitution in the enzyme, producing a variant enzyme that is, less stable. In practical terms, the C677T mutation leads to a less active MTHFR enzyme, impairing the conversion of folate into its active form and slowing the recycling of homocysteine back into methionine. Each person has 2 copies of the MTHFR gene, one from each parent. Heterozygous means you have 1 copy of the C677T mutation and 1 normal copy, whereas homozygous means you have 2 copies of C677T. These scenarios have different impacts. Heterozygous individuals retain roughly 65% of typical enzyme function, while homozygous individuals have significantly reduced enzyme function, leading to higher levels of unmetabolized folate and homocysteine. The MTHFR C677T mutation can have widespread effects on various bodily processes due to its role in the methylation cycle. A less efficient MTHFR enzyme impacts how your body processes nutrients and toxins. MTHFR's primary job is to convert folate into its active form, 5-methyltetrahydrofolate, or 5-MTHF. When someone has the C677T mutation, the reduced MTHFR activity means this folate conversion is sluggish, potentially leading to functionally lower levels of active folate in the body. This can impair DNA synthesis and repair and hinder the methylation of neurotransmitters and other molecules. MTHFR is crucial in converting homocysteine, a byproduct of protein metabolism, back into methionine by providing methylfolate. Vitamins B2, B12, B6, and folate are cofactors in this pathway. With an MTHFR C677T mutation, this conversion slows, leading to higher homocysteine levels. Methylation is one of the liver's key detoxification pathways. The methylation cycle produces methionine, which leads to the production of glutathione, the body's most powerful natural detoxifier. When MTHFR function is suboptimal, the chain of events that leads to robust glutathione production can be disrupted, potentially resulting in less glutathione and a diminished capacity to neutralize and eliminate toxins. One well-studied impact of the MTHFR C677T mutation is on cardiovascular health, largely through its effect on homocysteine levels. Elevated homocysteine is associated with an increased risk of cardiovascular issues. People who are homozygous for C677T often have mildly to moderately higher homocysteine, which could translate into a higher propensity for heart disease or stroke over the long term. Proper methylation is vital for the brain and nervous system. The production and regulation of neurotransmitters depend on methylation reactions. People with MTHFR mutations sometimes report issues like brain fog, memory problems, or mood disorders. Lower folate and higher homocysteine have been linked to an increased risk of depression, and anxiety. Beyond the biochemical details, MTHFR, C6N7T can also affect how you feel on a daily basis. Many individuals with this mutation notice differences in their mood, clarity, sleep, and how they handle stress or exercise. MTHFR plays a role in synthesizing neurotransmitters that regulate mood, as well as in breaking down excess stress hormones. When your methylation isn't optimal, you might experience more mood swings, anxiety, or even depression. Many people with the C6N7T mutation report heightened anxiety or feelings of being on edge, as well as brain fog. MTHFR can influence your sleep. Good sleep relies on a balance of hormones and neurotransmitters. If you have an MTHFR mutation, a cascade of events can lead to sleep disturbances. Many with C6N7T report problems such as insomnia, restless sleep, or not feeling rested upon waking. Chronic stress and anxiety can be exacerbated by an MTHFR C6N7T mutation. Methylation helps break down excess adrenaline and cortisol and is involved in the synthesis of calming neurotransmitters. If your MTHFR isn't working efficiently, you might find that stress hits you harder, or that it's tougher to come down from a state of high stress. Eat folate-rich whole foods like dark leafy greens, cruciferous vegetables, asparagus, avocado beans, lentils, citrus fruits, and nuts and seeds. Avoid synthetic folic acid, which is often added to processed foods and common in multivitamins. Balance your plate for methylation by including other supportive nutrients like vitamin B6, B12, and adequate protein intake. Certain supplements can be extremely helpful for those with MTHFR C6N7T. Methylfolate, methyl B12, riboflavin, vitamin B6, magnesium, omega-3 fatty acids, and glutathione or NAC can significantly support the methylation cycle and mitigate many issues caused by the mutation. Adopting daily detox supportive habits is very helpful. Stay hydrated, sweat it out through exercise or sauna use. Eat cruciferous vegetables, consider herbal supports for the liver, and minimize toxin exposure. These strategies can help your body compensate for reduced detox efficiency due to the MTHFR C6N7T mutation.